So today we're talking about mixtures and solutions. And can you see the phases? So let's just start with some basic stuff. So I think you're actually familiar with what a mixture is. This is two or more types of atoms. They are not bonded together. There's no chemical connection. There's a physical mixture here. And so mixtures can take lots of different forms. You can have two solids, you can have two liquids, two gases. You can also have more than two. It can be any combination of these things, solids, liquids, and gases as well. So here's some examples of solids that are mixtures. I have a pill has different mixtures of different medicines within it, different compounds within it. Here's a tin filled with different coins. There's different mixtures of spices in this jar. Here's some liquids. Water and coffee, that's a mixture of different liquids. Here I've got oil, vinegar, and water, and then orange juice has sugar in it, and water, and all sorts of different liquids. The different mixtures of gases, maybe the 3 different gases, I don't know what those are, but yeah, straightforward. So there's 2 major types. So the first one is heterogeneous. We've gone over these words before too, and the second is homogeneous. Homogeneous, you can remember homo is the prefix for same, and heterogeneous, hetero is the prefix, which means different. And so if something has a heterogeneous mixture, if something is a heterogeneous mixture, you can see the different parts. You can see the different, it's like salt, water would be homogeneous, whereas because you can't see the salt in the water. However, sand is an example of a heterogeneous mixture because you can see the different particles, the different types of grains of sand within the mixture. So here's some heterogeneous mixtures so you can see the different types of leaves, different things in soup. Whereas homogeneous mixtures just all kind of appear to be the same thing. So which kind of mixture? Well, here I have 3 different things. Whoops, you already got the answer. Classify each type of mixture as either heterogeneous or homogeneous. What do you think? Is this heterogeneous or homogeneous? Yeah, if you said heterogeneous, you're correct because you can see the different parts. How about this grape juice? Right, homogeneous is also correct. And then lastly, these delicious candies are heterogeneous as well. So when we're talking about these different types of mixtures, I do want to go over different ways that we've, before we move on, actually, there's different ways to separate mixtures. The individual components of a mixture keeps the properties. So that means that the properties of the components in a mixture can be used to separate them. And there's lots of different ways to separate mixtures. So if you have iron filings in some sand, you might use a magnet to pull them out. If you have salt and water, you can use a hot plate and you can evaporate the water out of salt water and you'll be left with salt crystals in the bottom of a plate. If you have muddy water, you could filter it. You could put it through a filter or even use a high power filter and clean it as well. And then I want to talk about 2 more things with mixtures. And the first one is called a colloid and the second one is called a suspension. So a colloid is a heterogeneous mixture that has small undissolved particles that do not separate out or settle if the mixture is undisturbed. So a glass of milk is a good example of a colloid. If you left it out on the table for a couple hours, it would still look white. The fat and the water particles do not separate. And the particles of colloid are too small. You can't see them with a microscope. They're too small. Yet they're large enough to scatter a beam of light. This is why it's not clear. You can't see through a colloid, whereas you can see through grape juice. And the second type of mixture that you can classify is called a suspension. So let's say you take a glass of really muddy water and you let it sit for a while, then you might notice that there is a cloudier layer that kind of appears either at the top or the bottom. And what you're likely looking at is called a suspension. So this is when this is a mixture with particles that can be seen as easily separated by settling or filtration. So olive oil and vinegar is a perfect example. Salad dressing, that oil separates on the top and the vinegar kind of goes to the bottom because of different densities. Let's keep cruising. So within a solution, let's talk about solutions next, right? So grape juice, which we have here, this is clearly grape juice, is one example of a mixture, and it's called a solution. A solution is a homogeneous mixture of a solvent and one or more solutes. So let's talk about what that means. The solute solutes to the solvent. So the solute is the part that is being dissolved into the solvent. It dissolves into the solution. The solute solutes to the solvent. That's how I've always remembered it. Now, if you want, you can also imagine Mr. Canapeel saluting when I tell you this analogy. So let's think of a couple more examples of solutions. So air is a good example of a solution. The air around us is a mixture of oxygen and nitrogen and several other gases. And nitrogen is the majority. It's like 73% nitrogen, the air that we breathe. And so nitrogen in this case is the solvent. There's more of it, and so everything else dissolves into the solvent. Iron, the metal, is also an interesting solution as well. Iron itself is not an element. It's made up of, stainless steel is what I'm talking about. Iron is indeed an element. Stainless steel. So like if you go underneath your cabinet right now and you look for a pan or maybe even the silverware that you eat with, that shiny steel, stainless steel, is also a solution. It is made up of a couple different elements. Iron being one. That's where the iron came from. And chromium is another one, and nickel. And it's a homogeneous mixture. And so in this case, it has the same properties throughout the entire mixture. Now, there's a couple different kinds of solutes. You can take this concept further, and the first one's called a molecular solute. So table sugar is a molecular solute. It breaks up into individual molecules within water. You can dissolve sugar in water, which makes Kool-Aid or iced tea sweet. And the sugar molecules, they move away from each other because the water molecules attract the sugar molecules. Remember that water is polar. And so while the water molecules surround the sugar molecules, the chemical bonds don't break. Remember, this is just a physical mixture. It's not a chemical bond. And polarity is super important when it comes to dissolving. And so non-polar molecules, like sugar is polar, non-polar molecules will not dissolve in water. They're not soluble in water. So ionic solutes, so table salt is mostly made up of the ionic compound called sodium chloride. We talked about that. It is an ionic compound. And sodium chloride is made of positively charged sodium ions and negatively charged chloride ions. So this allows for the salt to dissolve fully in water because it is polar, it is charged, and water is also charged. So just to recap this concept of solutions, it's a special type of mixture, and the solute dissolves into the solvent. So how do you make a solution? You put a solute into solvent, it dissolves, and you get a solution. So concentration or solubility is the next concept. So how we measure the ease at which a solute will dissolve into a solvent is called solubility. If something has high solubility, that means that the solute dissolves quickly and easily. So salt dissolves pretty quickly and pretty easily into water. Whereas sand does not dissolve quickly or easily, actually, really ever in water. I mean, maybe eventually if we're spinning it and agitating, eventually it might dissolve, but not really. And so dilute versus concentrated is the next concept. So you can add a little or a lot of a solute. So if we're talking about sugar in tea, if you put 1 spoonful of sugar, it's a small amount. If you put a lot more, it's a large amount, obviously. And we call a solution that has a small amount of a solute. So if you don't like a lot of sugar in your tea, then that's called a dilute solution. So diluted, this tea is very diluted. My mom used to make Kool-Aid when I was a kid, and she would put like a quarter of the sugar you're supposed to put in it. It tasted terrible. If you have a lot of sugar, if you're lucky and you get a lot of sugar or a lot of a solute put into the solvent, you have something called a concentrate. And when something is concentrated, it has unique properties as well. For example, solutes can raise the boiling point of a solution above that of the solvent. So if I add sugar to water and I make a sugar water solution, the boiling point will increase. So instead of 100 degrees Celsius, if I add salt to water, salt water boils at 102 degrees Celsius. But it also can lower the freezing point at the same time. So let's see. So if the surface of a lake freezes at 0 degrees, a salty ocean will freeze at negative 1.8 degrees Celsius. So it lowers the freezing point. And if you add more solute to a solvent, it makes it denser at the same time. And so you can actually feel that when you're swimming in the ocean. You're more buoyant. You float to the top because the water is dense, more dense than regular water in a pool. And so boiling point, freezing point, and density, these are all physical properties of solutions. And actually concentration is a physical property as well. The salinity of salt water, the saltiness of salt water, is all about the concentration of sodium chloride in water. Okay, let's keep rolling. So temperature is an interesting one. So in general, if I raise the temperature of the solvent, it increases the solubility of a solid solute. So this is why we make soup broth on a hot stovetop, because the solvent has a higher temperature. The higher temperature means that the molecules of the solvent are moving faster, and these more energetic particles, they can move easily, they can more easily break up the solid solute. So eventually, you can't add any more of a solute to a solvent. And when this happens, it's known as something being saturated. You can think of like an example of like a sponge. You can add water and a sponge will soak up that water, and you can keep adding water to a sponge and it will continue to soak it up. And then eventually that sponge is eventually fully saturated. You can't add any more water. And when that's the case, you've created something saturated. And what it looks like within the solution is if I add sugar or salt to water, eventually it will no longer dissolve. You can keep stirring it and stirring it and stirring it, but it's not going to dissolve anymore. But this is only true at a certain temperature, because I can keep going. If I heat up my solvent, we can even put more of a solute than normal. And when that's the case, we have something called a super saturated solution. So this is an example of this is regular saturation amount. If I heat it, I can add more, super saturated. And actually, pressure has little effect on solubility of solids. It does affect solubility of gases. So this is where it gets a little bit tricky, because usually when you think of solutions, you really just think of liquids, but it can also be gases as well. And so the solubility of a gaseous solute increases as pressure on the solution increases. So this actually is a good one. You don't want to get decompression sickness. They call it the bends when you're a scuba diver, because under normal atmospheric pressure, so if you're standing at the beach, nitrogen is not soluble in your blood. The nitrogen you're breathing, it doesn't go into your blood. But when you go underwater and the pressure increases, the air that's going into your lungs, it is also more pressurized. And when you go deeper than like 60 feet, the pressure of the air inside your lungs can make nitrogen soluble into your blood. And that's bad news. That's when you can get something called decompression sickness. So yeah, pressure can have an effect on it. So that's kind of the concepts. Feel free to shoot me any questions. We're going to do a couple more activities with this, and I look forward to hearing from you. Bye.